All right, we're starting up 14.1. This is a chapter on multiple integrals. So if you didn't watch the video, I hope you do. Remember when we're doing multiple integrals, or learn if you didn't watch the videos, we do the inner integrals first and treat the outside variables as constants. So in this case, x is a constant while we integrate y. In fact, if I said c equal 2x, I could just say this was c minus 4y. And when I integrate, it might be easy to see that that becomes c times y minus 2y squared, evaluated from y equals -1 to y equals 1. And we still have our outside integral there, 1 and 3 dx. And I'm going to put the c back in now. So assuming I didn't make a mistake, does it make sense?
Brings me memories of physics.
Damn you, Quinn.
He was about like 2 weeks early.
That's it. I remember hearing double integrals like it feels like a month ago.
Oh, maybe, yeah.
Like opening day.
Yeah, he
Is ready for another?
and differentials too. Or partials.
All right, let's do another. And if I need to bring that back, let me know. In fact, I plan on bringing it back in a second. After we do this one, I'm going to bring it back. Oh, Ben, triple integrals are in 14.5. Look, you get me bringing it in today. Ah, that's okay. We're still doing it. Remember, we're working outwards or inwards going outwards. So we got to do Y first. That should be what you have after you get rid of y. And cosine of 0 is just 1. Well, minus should be a plus. You guys following? All right, so this is an example where it's pretty handy to point out something else that's going on. I'm going to rewrite the problem. We know what the answer is. Let's rewrite the problem. I'm writing this kind of big. Now, I said when we're integrating with respect to y, we're treating x as a constant, right? So sine x would be a constant, right? Sine x is a constant with respect to y. So according to the rules of integration, I should be able to pull it outside, right? What happened here? There we go. And now, if I look at the bigger picture, if I look at the big picture, this whole integral here, 0, when I integrate this is going to be a constant. So I can pull it out of the x integral. So when you can do this, I made it 2 separate single integrals, right? We can do this when we have a function of x and y, and it's separable into a product, g of x times h of y. So we can separate it like that. it's pretty important to note that you don't want y shouldn't be a function of x. When it is, we're in, there's more going on than just swapping the order of the integrals or doing something like this. Because then if y was a function of x, then we would have x in the limits of integration. And we don't want that. Same thing with x equals y. We could take this a step further and work backwards. This is a constant, and I can plug it back into here. So I could make this 0 to 1, and then I'm moving the 0 to 2 sine x dx inside of the y dy function. I'm treating it as a constant. And the constant can go back in. And again, y is a constant with respect to x. So I could move y in. And I'm left with 0 to 1, 0 to 2, y sine x dx dy. So notice what I've done here. From where we started and where we ended, we swapped the order of integration. And we can see it here. We got the dx and dy here. Up here it was dy and dx.
And you said this only happens when it can be separated into a product of the two.
Yeah.
It happens
If you
when-
can, like up here, but why even bother? If you can separate it into two integrals, this is easier to do than this every time. Just less mental work. This is a quick plug and chug. I got 1/2 y squared evaluated from 0 to 1. I know that's 1/2. And I got negative cosine x from 2 to 0 is just negative cosine 2 plus cosine 0, which is 1. So I've got 1/2 times negative cosine of 2 plus 1, which is what we have up here. Here, you got to stop and make sure you're not. Y sine x is pretty straightforward one, but there's other ones where it's much easier to do two separate single integrals. So we learned a couple things there. We can swap the order of integration. This is much easier over a rectangular region, like we're doing here. I apparently can't hear you. Why? Did you mute yourself? Because I heard Jamie. Okay.
Yeah, I'm on the Zoom call.
Yeah, but Brandon's messaging that apparently the class, I can't hear the class. And I thought you guys were being unusually quiet, but okay. If there are questions, let me know, Brandon. I wonder what happened to the mic in the room. All right, so swap the order of integration. We want to definitely make sure that the variables are not functions of each other. If we do, it's not as simple as swapping the order of integration as it is, as we'll see tomorrow when we're doing 14.2. Let's kick this up a notch. Well, let's go back and revisit this problem here. So we can swap the order of integration here. I'm not going to do that. I did want to point out the next thing that we can do is when we have two things, this I can treat this as a function of xy minus another function of xy. I could narrow it down to just x and y, f of x minus g of y, but I don't want to do that for this example. The point is that I've got two different functions. I can break this up into two integrals. Oop. So that's a valid thing to do. When there's plus or minus, we can separate them into separate integrals. And now I could treat this as, I can separate it. I can do, let's see, dy goes with -1 to 1. I've got -1 to 1 dy, 1 to 3, 2x dx. Or I could put the 2 over here, but I'm not going to. And I could do this one, -1 to y, -1 to 1, 4y dy times 1 to 3 dx. I don't know that I would do that on this, but I'm pointing out things you can do in case you find certain things easier. Or I could take it and put the 4 over here, makes it a little bit easier. What happens if I don't? What's going on here? What is the function here that I'm integrating if I just have that? I can't hear you guys. I forgot. When you don't have a constant in there, there's nothing in there. We really have a 1. So that would just be y evaluated 1 minus 1. So we're not going to redo the problem. If you did, you should still get 16. But the point, I wanted to point out that we can treat it as two separate variables. Sometimes that's easier to do. And even though it didn't start off as a product of two things, 2x minus 4y is not separable as it is, because it's not a product. It's addition or subtraction. That is not the rule we had with f of xy equals gx times hy. So that's not separable. But if I split it up like this, then I can make each sub thing separable. So keep that in mind.
Brandon just texted the chat saying that he was going to try to fix the mic problem. Just letting you know.
Okay, Brandon, I'll wait. While you're doing that, I'll keep talking. So do not treat this as, let's see, 1 to 3, 2x dx times -1 to 1, -4y dy. That is not valid. Because this is now a product. This is, if I put them back together, this is -8xy. And that is not the function we started off with. That is not 2x minus 4y. So trying to avoid common mistakes that might happen.
Okay, testing. Oh,
I can
gosh.
hear you.
All right. Oh my gosh, that might.
There's an echo in there. With that in mind, and Ben's request, let's kick it up. Let's just throw a triple integral in here. Even though that's not in this section, can we reason out what's happening here with a triple integral?
I'm trying to think.
There's two mic inputs in the room. That's got to be what's happening.
Let me try reading.
Oh, you're logged in twice. Just mute one of them. You've got them both muted now. There we go.
We'll try that. The problem
There we
is,
go.
oh my gosh, it's still echoing. Because it's coming out of these speakers as well.
Oh, okay. Mute your computer. I assume you have a laptop and you're doing that.
Yeah. But you guys,
Yeah,
you
still
can't
it's
hear
coming
that.
through me. That's not going to happen. You'd have to mute the other one. That's not helpful.
Well, there was a problem.
It's a bad trip. This is a great example where doing this and then doing this and then doing this sucks. It's not complicated. It's just going to take up a lot of space on your page. Yes, that's the word I would use to describe it. Beautiful and angelic. You missed angelic, Brandon. I think this takes up a lot less space on the page if I had 4 to 6, and that goes with DZ. And I had -3 to 7, and that goes with DY. And then I had 5 to 2, and that goes with DX. So this is Z evaluated from 4 to 6 times Y evaluated from -3 to 7 times X evaluated from 2 to 5. So triple integrals aren't really much different when they're simple integrals like this. As soon as we start introducing one variable as a function of the other, this gets a lot more tricky. And that's why we tend to do triple integrals. Look at that, way over here in 14.5. Look at that, triple integrals in cylindrical and spherical coordinates. What? Fun time. Equals 60. Before we whip out the truly fun problems, In fact, let's go through that like we didn't do it. Let's see how long it takes to do if I were just to go, okay, this is x evaluated from 2 to 5, dy dz. That's 4 to 6, -3 to 7. 5 minus 2 is 3. I got 3 dy dz. So this becomes 4 to 6, 3y evaluated from -3 to 7 dz. This is 21 minus -9. So that's 30 dz. So 30z evaluated from 6 to 4 is 180 minus 120, which equals 60. So we can still get there. The numbers are bigger to work with at some point. And thankfully, 30 times 6 is easy to do in my head, but sometimes that multiplication isn't. It's much easier when you can to separate the variables. Or separate the integrals, I should say. Okay, something else worth pointing out. When we do like we're integrating from 0 to 2 of x squared dx. What we're doing is we're finding the area under the curve. So this is area. This is old news. This is beginning Calc 1. The triple integral is not what I wanted to show this on because it's not a good example. It's in fact, it's a terrible example for it. When we're switching to a double integral, though, what we have going on is something like this. We're integrating along x and y. We have this surface right here, but the function we're integrating is a surface that's above it. So we've got an area below. Oh, reshare. I want to annotate. We've got an area below, and this is at a height z equals the function. So what we're actually uncovering, area times height, is volume. So we're no longer finding area when we do this in a double integral, we're finding volume. We got little dx's going along this way. We got little dy's going along this way. And then we're integrating upward for each block. We're finding the volume for each rectangle, or parallel pipette, really, because the surface is at the top is not necessarily flat. We can take advantage of this though. When we have a crappy function in terms of y and f of x, we could make a surface z equals 1 and compute something that is a function y equals f of x. If we turn this into a z equals 1, we can turn this into make it a double integral. And finding the volume is the same thing as finding the area because h equals 1. We'll do that tomorrow, which is kind of neat. Let's give you guys another one to do right now. There you go. Let's work on that one for a second, see what we come up with before the 10 minutes are up. So I think the easiest thing to maybe do here, just to make sure it's clear as what's going on, I'm going to just say u equals x plus y, and then so du equals dy. And if I do this, I've got a couple choices. I can either, I'm definitely putting this in. I've got, this is 1 over u squared now, which is u to the negative 2 du dx. I have choices on my limits of integration. And you have to be clear on what you're doing. If I want to keep the 1 and 2 as is, I need to say y equals 1 and y equals 2. You need to be very clear that this is y and not u. The other option you have is going, okay, when y equals 1, u equals x plus 1. And when y equals 2, u equals x plus 2. And I can relabel these as such and not have to worry about writing the y in. These are both valid. If you do the top one, after you integrate, sub x plus y back in for u. The second one, you don't have any more work to do. You're just doing it as is. In no case if you put, this shows up on a test and you have 3 to 4, 1 to 2, u to the negative 2 du dx, you're losing points. Because this says the limits of integration on u are 1 to 2. And that is not what's happening. So be very, very careful about that. If you make substitutions, you have to be careful on what you're writing for your limits of integration. You may know what you're doing, and the people that are more likely to make this mistake are the ones that are naturally more gifted at mathematics. They don't have to work as hard. I used to hate this as a student because I'm like, I know what I was doing. Why do I got to write this shit in? Well, sometimes the problem gets a lot going on. You get distracted. First off, without regarding a test or anything like that, you get distracted. Someone's phone goes off or something like that, or you're at work and your phone rings and you take the call for 10 minutes. And by the time you're done taking the call, you done forgot that this represents Y and not you. And then you go through and work the problem out doing that, and it ends up being wrong. You get the wrong answer. So there's a reason for doing it beyond the fact of whether or not you're getting graded on it. The other thing is, if you're doing some work and you're working with a team or something like that, you need to be clear. So if people are checking your work or anything like that, your shit makes sense. I think I'm going to do the latter one simply because that's the one you're least comfortable with. And so it's probably better to see it worked out. So let's go with that one. I'm going to get rid of that. Get rid of that. And just write what we got here. If we integrate this, we go up a power, divide by a power. I got negative 1/3 u to the negative 3, which is negative 1/3 u cubed du, or d, where u is evaluated from x plus 1 to x plus 2. Then we got a dx. This is 3 to 4. Let's move the negative 1/3 out front. 1/x plus 2 cubed minus 1/x plus 1 cubed dx. Again, if you want to do a u sub here, we can. We kind of need to break this up into two integrals. So maybe I'll do u and v. Du equals dx. When x equals 3, u equals 5. When x equals 4, u equals 6. So I got negative 1/3, 5 to 6 of u to the negative 3 du. Minus, I'll put the minus with the negative 1/3 over here and make this plus 1/3. And then we'll do v equals x plus 1. Again, dv equals dx. But when x equals 3, v equals 4.
Hey, Jones, they're calling you.
What?
They're trying to get a hold of you, I think.
What did I do, Lawrence? My bad arithmetic. Where is there a negative 2? Oh! Fucking scrub. Scrub. You're right. Upper power is -1. This is -1 over you. Thank you. Terrible. So that would just be a negative out front. God damn, that's terrible. Thank you. Or I think probably when you see it with the exponent like this is a lot easier to recognize without doing the U sub, U and V sub. We're going to get natural logs, right? In fact, if I put the negative in, I can just change the order of this and make it 1 minus like that. So I probably wouldn't do U and V. This is natural log of x plus 1. Evaluated from 3 to 4. Oh, I might as well just do it all at once. So we have natural log of 5 minus natural log of 6 minus natural log of 4 minus natural log of 5. So I've got 2 ln of 5 minus ln of 6 minus ln of 4. This is ln of 5 squared. Oh, some log rules. So this would be ln of 25 minus ln of, ooh, more log rolls. Put those together. And I'll finish it off. Your final log roll. Subtraction leads to division. Did I fuck anything else up? Could I go over the U sub like up here? Yeah. So I was doing a U sub for this one. Are you guys okay up to this step? Writing in the sub? Is that thumbs up? All right, so u to the -1 still ends up being a natural log. So it would be natural log of u from 6 to 5. And we had a negative. Get rid of all that extra stuff. We ended up having 25 over 24. Let me just make a note of that. Up here, I would go, we've got natural log of u from 5 to 6, negative natural log of u from 5 to 6, plus natural log of b from 4 to 5. This is negative natural log of 5, or negative natural log of 6, plus natural log of 5. And then I've got plus natural log of 5 minus natural log of 4. And we get back around to where we were before. 2 ln of 5 minus ln of 6 plus ln of 4. I assume that's all good. We're all good. See you guys tomorrow. Everybody else is gone.
Yeah, we're all good. No, that's mine.
See you guys tomorrow.
Yeah.